Lesson 11.2, Task 3. Rewrite rational functions in order to graph them. When given a rational function of the form g of x equals mx plus n divided by px plus q, where m is not equal to 0 and p is not equal to 0, you can use long division to rewrite the function in one of the general forms g of x equals a times 1 over x minus h plus k, or g of x equals 1 over b times x minus h all plus k, in order to identify key features of the graph, and graph the function. Use long division to rewrite the function g of x equals 2x plus 3 divided by x plus 1 in one of the two general forms given above. Then graph the function. All right, so we did long division a couple units ago. Okay, so if you remember here, we can go ahead and do it as well. They've got it written down here, but I kind of like to go through the process myself. So I get my pen to work here. All right, so we've got x plus 1, and we've got 2x plus 3. All right, so again, we are dividing, and writing it like this is just being able to do long division. When you have a fraction like this is division as well. So all we're doing is rewriting it so we can do long division. All right, so we're going to have x goes into 2x 2 times. 2 times x is 2x. And then 2 times 1 is 2. And then remember, we always subtract the row underneath. So we're going to subtract. And then 2x minus 2x cancels. 3 minus 2 becomes 1, and that's our remainder. And our remainder goes over our what we're dividing by. So I'm going to put 1 over x plus 1. All right, and so you can see that they got 2 and they left the remainder here. So it says the quotient is 2 and the remainder is 1. What steps were used to find the quotient and the remainder? Okay, so we did long division. Right here are the steps. And it says use the relationship among the divisor, the dividend, the divisor, the quotient, and the remainder to rewrite the equation for g of x in this way. All right, so this was given. 2x plus 3 divided by x plus 1. That was the original equation up top, g of x. And now we have 2 plus the remainder. So we've got 2 plus this is our new, our quotient plus our remainder over divisor. Now, we're going to put the 2 on the end just because it fits in that general form of g of x. Okay, so we want it to be in one of these two forms, either this form here or this form here. And since there's no b here, we're going to put it in this form right here. All right, so that means k, or just the constant term, is going to have to be on the end. So that's why we move the 2 to the other end. All right, so g of x equals 1 over x plus 1 plus 2. That's just using commutative property to put the 2 at the other side. No big deal. All right, why is this form of the equation more useful for graphing? Well, if it's in this form, we can determine what our parameters are, our a, b, h, and k, and then we can use those in order to graph the function. All right, so the parameters of g of x are a is 1, h was -1, k is 2, and it says identify the key features of the graph of g and sketch the graph. All right, so the first thing you can do is determine the isotopes, okay, because those come from your parameters. Since h is -1, we know that we're going to have a vertical isotope at -1. K is 2, so we're going to have a horizontal isotope at 2. And then you can use your reference points to sketch the curve from there, okay? All right, that is all for task 3. If you have any questions, let me know. 11.2, Task 4. Write simple rational functions from graphs. When presented with the graph of a rational function, you can use the features of the graph to write an equation for the function. The function can be written in the form g of x, and this is our general form here, or in the form, and this is our other general form here. This one has the a and this one has the b. Work through the following steps to write an equation or to write an equation of the graph shown. Use the form g of x. Okay, so that's our general formula here. So when we look at this, we can tell what our isotopes are. So that's where we're going to start. We know that this is our H and this is our K. So the first thing we can do is write down H equals, there's 0, 2, so H equals 1, and K equals -3. All right, we're also given reference points. We'll come back to the reference points. Let's go ahead and maybe write those down. Let's see, we'll probably need those. 0, -1, and 2, -5. All right, so we're just keeping track of the information that we're given from the graph. All right, so it says explore to see how to find the parameters h and k. All right, so we're probably going to use h and k with our, okay, so there's a vertical isotope at x equals 1, so the parameter h equals 1. Okay, so I already determined that. And since our other isotope is at -3, k equals -3. Substitute these values into the general form of the equation. All right, so they're telling us to go ahead and substitute it into the general form. So we're going to have g of x equals a times 1 over, since h is 1, we know our formula is x minus 1, and then k stays the same, -3. All right, now how are we going to find our a value? All right, so next choose either reference point shown on the graph, such as 0, -1. Watch and see how to substitute x coordinates for the reference points to solve for a. All right, so if you remember our two reference points, we had equations here, and the first one is -b plus h and -a plus k. And we could use the second reference points if we wanted to, but we don't have to. All we need to do is find a at this point, so we can use the first point to find a. Now, if we do that, we know that 0, okay, 0 has to equal -b plus h, so -b plus h. So 0 equals, we know h is 1, so -b plus 1. And then we solve for b. Okay, we don't really need b, but we can solve for a and b by using these equations. So b equals 1. And then we can use -1 and set that equal to -a plus k. And we know that k is -3. So we're going to have -1. Let's add 3 to both sides. So if I have -1 plus 3, that's going to be 2 equals -a. So a equals -2. So we found a and we found b. Even though we don't need b for this one, we know what it is. So now we can just take a and replace a with -2. All right, if you want to click on these, they're kind of hard to read, but it shows how to get a is -2 here. All right, so it says why can either reference point be used? Okay, so I used the first reference points, but because both reference points, the next one is b plus h and a plus h, both of those reference points allow you to find a and b. All right, g of x equals a times, this was the equation that we had here. Now we need to substitute -2 in for a. So if we substitute -2 in for a, that's going to give us this equation here. How can you check to see if your equation is correct? You can graph it on your calculator and see if this is what it looks like. All you have to do is when you graph it on your calculator, make sure you change the window to be similar to the window that it gives you, because that's the only way that it's going to look similar to that. All right. That is all for task 4. If you have any questions, please let me know.